The man who invented the generator was a genius. How did he generate electricity? The concept of generating electricity in a generator uses electromagnetic force. Its basic principle comes from Faraday's law. This law explains that when a magnetic field interacts with a coil, an electromotive force is generated. In simple terms, when a magnet moves near a copper wire, an electric current is generated. Therefore, a generator has two components, i.e., a stator and a rotor. The stator is the stationary component, shaped like a copper coil, and the rotor is the rotating component. Several magnets are mounted on the rotor. These magnets generate an attractive force, which we call a magnetic field. When these magnets continue to rotate near the copper coil, an electric current is generated. The concept is that simple. It's just a magnetic field moving near the coil. But is the electricity generated enough to meet our needs? In order to generate enough electricity, some engineering design is required. To increase the amount of electricity that can be generated, for example, the number of magnets and stator coils can be increased, but this will make the generator quite large. Increasing the rotating load, therefore, reduces the working efficiency of the generator. So how to generate high power while keeping the generator compact? We can increase the magnetic field without increasing the size. This can be achieved by replacing the magnets on the rotor with coils, because the magnetic field can not only be obtained from permanent magnets, but also be created with copper coils. The coils with power will produce magnetism. This is widely used in large generators. So there are two kinds of coils in the generator: stator coils and rotor coils. The stator coil is where the magnetic field is cut. The stator consists of multiple coils installed on the stator winding. Then all stator coils meet two terminals as output. The function of the rotor coil is to provide a magnetic field. Since this is not a permanent magnet, direct current needs to be passed to excite the magnetic field. The stronger the magnetic field formed, the larger the current. This is called a granular magnetic system, i.e., a system that provides an initial current to generate a rotor magnetic field. There are two types of granular magnetic systems themselves: external type and self-generated type. In the external type, the current comes from an external source such as a battery. This type is usually built into the alternator on the car, while the self-generated type uses a component called PMG, permanent magnet generator. This is a smaller size generator, but it uses permanent magnets as the stator. The PMG is mounted on the same shaft as the main generator, so when the main rotor rotates, both the rotors of the generator and the PMG rotate. This type is widely used in generator sets or large generators. So, how does it work? The working principle is almost the same as a general generator. There are two components, the rotor and the stator. The stator provides the magnetic field. In this case, permanent magnets are used, and the rotor is the coil that the magnetic field cuts. The rotor of the PMG has three, so there are three outputs. The current generated is AC, but in order to generate a magnetic field on the main rotor, DC is required. So there is another component: rectifier diode. A diode is a component that can rectify current, allowing it to flow in only one direction. The diodes used are connected in the following way. Current from the PMG enters from the middle, with several diodes installed in the same direction above and below. So the output of the rectifier is DC transmitted through the positive and negative terminals. Then the output of the rectifier is transmitted to the rotor coil. The coil on the rotor is a unidirectional coil, so there is only one positive input and one negative input. In this example, the rotor coil consists of 4 windings connected in series. When power is applied, it generates a magnetic field of alternating polarity. So on a shaft group consisting of the main rotor, PMG rotor, and rectifier, the three will rotate together. Since the particle system also rotates together, this does not require the use of brushes, so it is called a brushless system. When the generator rotor rotates, magnetic field cutting occurs in the PMG. The generated current is transmitted to the main rotor. When the main rotor is supplied with current, a magnetic field is formed, and a larger-scale magnetic field cutting occurs. Since the magnetic poles on the rotor are alternating, the direction of the current induction also alternates, which will produce alternating current sent to the voltage regulator for processing to meet demand. The rotation of the rotor can come from a variety of sources, such as windmills, engines, or other devices that produce rotational energy.